In a bold proclamation, scientists have announced a remarkable discovery of a new planet, unlike anything previously known. NASA, famous for its groundbreaking research, has disclosed that this planet is intriguing not only due to its size and location, but also because it emits light that seems to be artificial. Could we be on the brink of revealing secrets that might revolutionize our comprehension of the cosmos? Is it possible that this discovery suggests the presence of life beyond Earth? By diving into NASA's remarkable findings, we will soon uncover the truth behind these mysterious lights. In 2007, NASA launched the Dawn spacecraft with the goal of exploring some of the most captivating objects in our solar system. Armed with 3 ion engines, Dawn embarked on a journey that began with a 14-month investigation of Vesta, the second-largest asteroid in the asteroid belt. Dawn transmitted intricate images and data that revealed Vesta's intricate surface and its varied geological history. Once its mission at Vesta was completed, Dawn moved on to the second phase of its journey, one of the most thrilling aspects of the mission, the in-depth exploration of the dwarf planet Ceres. Thanks to its ion engines, Dawn was able to depart Vesta's orbit and make its way towards Ceres, something that conventional chemical propulsion would not have permitted. These engines provided a steady thrust, allowing Dawn to travel vast distances and achieve a stable orbit around Ceres. Discovered in 1801 by the Italian astronomer Giuseppe Piazzi, Ceres is the largest object in the asteroid belt between Mars and Jupiter. For many years, it was considered the smallest dwarf planet in our solar system until its reclassification in 2006. With a diameter of about 950 kilometers, Ceres is not only the largest and heaviest object in the asteroid belt but also one of the most captivating due to its distinct features. Scientists eagerly anticipated the first close-up images of this enigmatic world, hoping it would reveal new and exciting findings. These images unveiled bright patches scattered across its surface, especially in a large crater known as a crater, which sparked immediate interest within the scientific community. Before dawn, the best image available of Ceres had been a blurry, low-resolution snapshot from the Hubble Space Telescope, offering little insight into this dwarf planet. With the prospect of closer examination, scientists expected groundbreaking discoveries. The Dawn mission aimed to enhance our understanding of how the solar system formed and the role water played in the creation of planetary bodies. The bright spots on Ceres, which had also been observed on other asteroids, were believed to consist of highly reflective materials, possibly salts left behind by evaporated water. This finding hinted at the possibility of cryovolcanism on Ceres, a phenomenon where volcanoes erupt water or brine rather than molten rock. But what exactly were these mysterious lights, and what did they reveal about Ceres? Could they be signs of ongoing geological activity or something even more extraordinary? Ceres stands apart from other objects in the asteroid belt due to its size, mass, composition, and potential for containing water and ice. Unlike the typical rocky asteroids, Ceres has a more comet-like composition, which suggests it could provide further insight into the early solar system. After 2 years in transit, the Dawn spacecraft finally reached its destination in early 2015, marking a significant milestone as it prepared to deliver the first high-resolution images of the largest object in the asteroid belt. As dawn drew nearer, the images of Ceres became more detailed, revealing a world previously hidden from view. The initial pictures showed a cratered surface, indicative of a long history of impacts. What captured the attention of both scientists and space enthusiasts were the enigmatic bright spots scattered across the rocky terrain. As the image resolution improved, the scientific community began to form theories about the origin of these bright spots. Were they patches of ice reflecting sunlight? Or could they represent something even more unusual? Speculations ranged from mineral deposits to potential signs of cryovolcanic activity. To everyone's astonishment, closer inspection revealed that the brightest spots were not just a single entity but a cluster of several distinct spots. The most widely accepted theory was that these were deposits of salt left behind after water sublimated. This suggested that Ceres may still have, or may have once had, some form of geological activity capable of bringing water or brine to the surface, where it would quickly evaporate, leaving behind bright reflective salts. These findings challenged existing assumptions about Ceres, painting a picture of a more dynamic and complex world than scientists had previously imagined. The possibility that groundwater or brine pockets could exist raises intriguing questions about the potential for life elsewhere in our solar system. Ceres, often referred to as an icy world with a rocky, porous surface, stands in stark contrast to most asteroids, which are primarily composed of rock and metal. Its unique composition includes a mix of water ice and hydrated minerals, such as clays and carbonates, making it less dense than its rocky counterparts. This composition suggests that Ceres contains a considerable amount of water, and its surface is porous and rocky, with ice and other volatiles trapped inside, making it more similar to a comet than a typical asteroid. Scientists believe that Ceres has a distinct internal structure, consisting of a rocky mantle and a core rich in water ice, which accounts for roughly 50% of its total volume. Its mantle likely consists of a mixture of rock and brine surrounding a core that may contain denser materials like silicates. The presence of significant water ice indicates that Ceres could have once hosted liquid water, particularly if its core was heated by radioactive decay early in its history. This internal makeup distinguishes Ceres from its asteroid belt neighbors and raises fascinating questions about the planet's potential for geological activity and its overall evolution. The discovery of ammonia clays on Ceres further suggests that the dwarf planet may have formed in a cooler region of the solar system and later migrated inward. Ammonia's presence could lower the freezing point of water, thereby supporting the possibility of surface brine. These insights into Ceres' composition and history not only deepen our understanding of this fascinating dwarf planet, but also offer valuable clues about the processes shaping the evolution of icy bodies throughout the solar system. Cryovolcanism is a captivating and relatively rare geological process, especially when compared to the familiar volcanic activity we observe on Earth. Unlike traditional volcanoes that expel molten rock, cryovolcanoes, also called ice volcanoes, release substances such as water, ammonia, or methane, which exist as liquids or gases in extreme cold. Cryovolcanoes on Ceres function by allowing brine or water, mixed with dissolved salts, to reach the surface. Upon contacting the vacuum of space, the salt water rapidly sublimates, changing directly from a liquid or solid state to a gas, leaving behind glowing, reflective salt deposits. These salt residues form the mysterious bright spots observed on Ceres' surface. The most well-known of these bright spots is located in a crater called a crater, specifically in an area known as Spot 5. This region has drawn significant attention due to its high reflectivity and periodic changes observed by the Dawn spacecraft. These variations are believed to result from water sublimation, indicating that cryovolcanic activity may still be occurring or have occurred relatively recently on Ceres. In addition to Spot 5, Ceres hosts several other bright spots, each with its own distinct characteristics. These spots are scattered across the dwarf planet's surface, suggesting that cryovolcanism could be a widespread phenomenon on Ceres. The presence of these bright spots underscores the dynamic and active nature of Ceres, challenging previous assumptions that it was a geologically dormant world. As the Dawn spacecraft captured more detailed images of Ceres, a variety of surface features began to emerge. Ceres' surface is dotted with craters, each telling the story of the dwarf planet's ancient history. Please share your thoughts in the comments section. If you enjoyed the video, don't forget to like and subscribe. As more images and data from the Dawn spacecraft were collected, scientists began to uncover new and exciting details about the dwarf planet Ceres. The initial images, which first revealed the bright spots, were only the beginning. As Dawn approached Ceres closer, more intricate features of its surface began to emerge, presenting Ceres as a much more complex and dynamic world than initially thought. The discoveries were particularly intriguing because they shed light on a potential internal water reservoir beneath the surface of Ceres, a prospect that could have profound implications for the possibility of life beyond Earth. These findings suggested that Ceres, despite being an icy and seemingly barren world, could still harbor signs of geological and possibly biological activity. The bright spots, which were initially mysterious, became one of the key points of interest for scientists. These spots, initially thought to be patches of ice or frozen water, were later identified as reflective salt deposits, likely left behind by water that once evaporated or sublimated. This process of sublimation, in which a solid turns directly into a gas, could indicate the presence of underground brine pockets, suggesting that liquid water had once flowed or could still flow beneath the surface of Ceres. These surprising revelations raised more questions than answers. Could these bright spots be the result of a long-extinct volcanic process, or could they indicate ongoing cryovolcanic activity? The possibility that Ceres might still be geologically active, despite its cold and distant location in the solar system, challenged traditional assumptions about what we thought we knew about small celestial bodies in the outer solar system. Another significant discovery was the detection of ammonia, a compound that could lower the freezing point of water. This discovery provided more evidence that Ceres might be capable of supporting liquid water in the past, or potentially in the present beneath its icy surface. This opens up new possibilities for understanding how planetary bodies in the outer solar system can evolve and adapt to harsh conditions. These new insights into Ceres' composition and activity brought into focus the idea that Ceres may not be as dormant or lifeless as once believed. Instead, it could be a dynamic and ever-evolving world, driven by forces beneath its icy surface. Scientists are now more excited than ever to continue their studies of this fascinating dwarf planet, hoping that future missions or more detailed data from Dawn will reveal even more astonishing discoveries. The question of whether Ceres could harbor life, even in microbial form, remains an open one. While there is no direct evidence yet of life on Ceres, the discovery of liquid water or brine beneath its surface, combined with the evidence of organic compounds, could make it a compelling candidate for further study. The ongoing exploration of Ceres offers new hope for scientists looking to uncover the mysteries of life's potential existence beyond Earth. Moreover, the study of Ceres is not just about understanding one small celestial body. It also has broader implications for understanding the formation of our solar system and the conditions that might support life on other planets. If Ceres can harbor water beneath its surface, it suggests that other icy bodies in the outer solar system might also have the conditions necessary for life. This has profound implications for future exploration, as scientists turn their attention to other moons and dwarf planets within our solar system that may harbor similar conditions. While the Dawn mission has now concluded, its legacy continues to impact planetary science. The images, data, and discoveries it provided have significantly enhanced our knowledge of Ceres, and by extension, our understanding of the outer solar system. It has raised more questions than answers, but this is precisely the nature of scientific discovery. It is about uncovering new mysteries that spark curiosity and drive future exploration. In the coming years, as technology improves and new missions are launched, we are likely to learn even more about Ceres and other bodies in the asteroid belt. Whether or not life exists on Ceres remains to be seen, but one thing is clear: the Dawn mission has revolutionized our understanding of this enigmatic world, and it has opened up new avenues for exploring the potential for life elsewhere in our solar system. In conclusion, the exploration of Ceres and its fascinating characteristics have far-reaching implications for the future of space exploration.